Welcome back to the second video in the neuroanatomy video series. In this video, we're going to be talking about the diencephalon, specifically these structures right here. And the diencephalon is a kind of an interesting structure. It's really just the third ventricle and all the surrounding structures that make it up. So we're going to go deeper into those structures right now. So like I had mentioned, the diencephalon is really just the third ventricle and then the surrounding structures which make up its walls. So let's start by first identifying the third ventricle. First, we need to understand what kind of section we're looking at. So you can see this little emblem up here. This is the brain. You have the left and the right hemispheres, and you can see we're taking a sagittal section. So we're splitting right between the two hemispheres along that longitudinal fissure. And when we're looking at the brain from a sagittal section, you can see we have this outer cortical area right here. The first thing that I always look for to identify if it is a sagittal section is this structure right here. And if you remember from last time, this structure is the corpus callosum. So it's that white matter bundle which is going to connect our left and right hemispheres. Under that, we have right here, this would be a lateral ventricle. This would be the fornix. Not very important right now. We'll come back to these in future videos. But just under this fornix area, this is where our third ventricle begins. So we have an opening where the lateral ventricle drains into the third ventricle. And so the third ventricle really is just this space right here. And we're going to be talking about the structures which make up the walls of that space. So what are those structures? Well, first we have the thalamus. And the thalamus kind of looks like a little eye present right in the center of the brain. So this is the thalamus right here. And the thalamus makes up our lateral walls of the third ventricle. Now what makes up the anterior wall of the third ventricle? Well, that's going to be our hypothalamus. And the hypothalamus can be found right here. And the hypothalamus is really just the walls that make up that anterior portion of the third ventricle. We'll go into a little bit more detail in the coming slides. But finally, we want to talk about our posterior boundary, which is going to be the epithalamus. So our epithalamus is going to be found all the way at the posterior end of the third ventricle, and it makes up that posterior boundary. And a quick and easy mnemonic that I like to use to remember the different subdivisions of the diencephalon is the diencephalon. So we have the THE, which is going to represent the thalamus, hypothalamus, and epithalamus. So thalamus, hypothalamus, and epithalamus make up the diencephalon right here. So now that we've talked about the three major subdivisions of the diencephalon, let's take a closer look at the thalamus, the largest subdivision. So the thalamus really is just these two large egg-shaped multinucleated gray masses located just outside of the third ventricles. And what they do is they are like the relay station. So information is going to come into them, and the thalamus or the thalamic bodies are going to sort out that information and then send it to the appropriate areas in the cortex. And I think of it kind of like the post office. So we're sending all this mail into the post office, and then the post office needs to sort all this mail and send it to the appropriate address. It's kind of like what the thalamus does. It's getting all this information, it needs to organize it, and then it needs to send it out to the appropriate areas in the cortex. And it does this through these radiations called Thalamocortical radiations. And if you break that down, we have Thalamocortical. So thalamo coming from the thalamus, cortical going to the cortex. So they're radiations connecting the thalamus to the cortex. So again, here we have that sagittal section. We have our corpus callosum, which is, I always like to use as a landmark. And then we have our thalamus right here. So if we zoom into this area, we have our thalamus, which looks like the eye of the brain. It's going to be right here. And then found at the center, we have this gray matter bridge connecting our two thalamic bodies, and this is known as the interthalamic adhesion. Now that we view the thalamus from the sagittal point of view, let's take a look at it from a posterior point of view. So these are the two thalamic bodies on either side. This right here would be our diencephalon region, and you can see it's sitting on top of our brain stem right here. Now if we were to color in our thalamus, it would look something like this. And it's not very present here, but our interthalamic adhesion would be found right in here. This would be our third ventricle located right here. And just to note it here, this is our epithalamus region back here. So now that we've proven we can identify it in a sagittal section and viewing it from the posterior view, let's take a look at a coronal section. So you can see here's a coronal section. We're basically splitting the brain into anterior and posterior sections. So we'll say this is an anterior view looking posteriorly or backwards. So in order to identify the thalamic bodies, let's try and orient ourselves. So here's that outer cortex. This is that gray matter area. If you come in, here's that corpus callosum again. It's going to be that white matter bridge connecting the two hemispheres. And you can see just under that corpus callosum, we have our ventricles. So this would be our third ventricle right here. And forming the lateral walls of the third ventricle, remember, we have our thalamic bodies. So this would be one thalamus, and this would be another. And then found situated between our thalamus, we have that interthalamic adhesion right there. Now let's move over and look at this on a horizontal section. So here's our reference image, cross section, dividing into superior and inferior is a horizontal section. So think of this as a superior view looking downwards. And then we would have the right hemisphere and the left hemisphere. And these dark structures in the middle, these are actually our ventricles. So we would have our lateral ventricles right here. And then directed along that midline, this would be our third ventricle. So that's a good indication of where our thalamus is going to be. So our thalamus is located just right here. And then again, situated between the two, we have that interthalamic adhesion. All right, great. Now that we can label these on coronal, sagittal, and horizontal sections, let's take a look at a brain scan and see what it looks like on here. So you can see from this brain scan, here's the reference image, suggesting that it's the sagittal section dividing the left and right hemisphere. And we're looking at the midline structures. I'm just going to zoom in a little bit. You can see here, that's that corpus callosum. That's our lucky landmark. Here's going to be the fornix that I mentioned at the beginning. This whole area right here will be our diencephalon. And you can see this kind of eye right at the center, right on top of the midbrain of the brainstem. This eye right here, that is going to be our thalamus. So let's just color that in. And it's not very visible, but between the two thalamic bodies, again, we would have that interthalamic adhesion. I'll just throw a dot in there. So let's just get these labeled. So now let's talk about the second major subdivision of the diencephalon, which is the hypothalamus. Now the hypothalamus is kind of similar to the thalamus in the sense that it is made up of multiple nuclei which receive afferents from the upper cortical areas, which help regulate our endocrine system. So this is considered part of the neuroendocrine system, and this acts as the connection between the nervous system, so receiving input from the cortex, and the endocrine system, so distributing chemicals throughout our body, which will have a global effect on the body. We're still looking at this from a sagittal point of view. Again, have that corpus callosum. And then the hypothalamus is going to be a little bit anterior and inferior to our thalamus right here. And we can use a number of certain structures, particularly this one, and this one, to form a triangle of where we're going to find that hypothalamus. So let's label these structures. First, we have the anterior commissure, and the anterior commissure is going to be the most anterior boundary of that triangle. And the anterior commissure is a white matter bundle similar to the corpus callosum, which extends from the left and the right hemispheres. And then if we move just inferior to the anterior commissure, we have this structure right here. This is actually the optic chiasm. It's one of our cranial nerves, or it's part of one of the cranial nerves, the optic nerve 2. And this is where the optic nerves converge, exchange information or decussate, and then continue on as optic tracts. And then finally, towards the back, we have the mammillary bodies right here. And so you can see we formed this triangle right here. Now, what is this boundary between the thalamus and the hypothalamus? Well, this is going to be the hypothalamic sulcus right here. And that forms our triangle, as you can see right there. So let's just color in the hypothalamus. And it's also worth mentioning two other structures, the infundibulum and the pituitary gland. So let's just get these labeled. We have the anterior commissure, the optic chiasm, the infundibulum, the pituitary gland, the mammillary bodies, the hypothalamic sulcus, and of course the hypothalamus itself. Now that we've identified all the structures of the hypothalamus, let's take a look at it on a brain scan. So here's a sagittal section of an MRI, and we've just zoomed it in and blown it up. So you can see here, that's our corpus callosum right there. We're going to have our eye in the center of the brain, that's going to be our thalamus. And then inferior and anterior to that thalamus, we're going to have this space right here, and this is going to be that hypothalamus. So let's just go and label a few things. We have the anterior commissure, the optic chiasm, and the mammillary bodies. And these three structures are going to make up that triangle, as you can see right here. And we also have the hypothalamic sulcus, which is between the hypothalamus and the thalamus, which is found right around here. And then remember, extending off of the hypothalamus, we also have that infundibulum, and we also have that pituitary gland right here. And then finally, we have our hypothalamus, which is the area found between all of these structures. So as you can see, identifying these structures on an MRI is not too hard. We just need to look for our landmarks and keep in mind our neuroanatomy. So finally, let's talk about our third major subdivision, which is the epithalamus. This is going to be found in the posterior aspect of our third ventricle, or a diencephalon, however you want to classify it as. And the epithalamus is really made up of three main structures, the most notably being the pineal gland. The pineal gland is the gland responsible for producing melatonin. Melatonin is a special hormone which actually puts your body into rest and helps you fall asleep. And this does so by communicating with the suprachiasmatic nucleus found in the hypothalamus. Melatonin and the pineal gland respond to our circadian rhythm, or our sleep-wake cycles. So during the day, our body is awake, and during the night, our body is shut down, and it allows us to rest and recover. Again, that is our pineal gland. Coming inferiorly off of the pineal gland, we have this C-shaped structure. And this is our posterior commissure. And this is similar to that anterior commissure in that it's a white matter bundle, which is going to connect both hemispheres of our cerebral cortex. It's not exactly understood what it does, but it's used as a landmark to identify our pineal gland. And then finally, we have the habenular commissure right here. And this is going to be coming off the superior aspect of that pineal gland. And this is connecting the habenular nuclei on the posterior aspect of the thalamus to the pineal gland. So these three structures, the pineal gland, the posterior commissure, and the habenular commissure, all make up the epithalamus. So what does this look like on an MRI? So if we look at that same image of our brain scan, let's zoom in. And so the one thing that I'm always going to look for is the C-shaped structure. So that is our posterior commissure right here. We then, coming off of that, have this structure right here. This is that pineal gland. And then coming up here, we're going to have those habenular commissures. So HC, that's our habenular commissure. PG, that's our pineal gland. PC, which is going to be our posterior commissure. And all three of those structures are going to make up our epithalamus. So now we got an extra brain scan. Let's look for some structures on this one. This is a horizontal section, as you can see right here. So again, we're just cutting right through the brain. When looking at a scan like this, I like to find the ventricles. So you can see here's going to be the anterior horns of the lateral ventricles, and here are the posterior horns found within the middle. This is going to be our third ventricle. So if we know that this is the third ventricle, what makes up the walls of the third ventricle? We're going to have those huge thalamic nuclei right here. So let's just go in and label these. It doesn't show up as nice as I would like it to, but these bad boys, these are going to be our thalamic nuclei. You can kind of see a little bit of that interthalamic adhesion right in the middle. And then posteriorly coming off of it, we have these guys. These are going to be those habenular commissures. And then we also have this structure right here. What is that? That's going to be our pineal gland. So you can see it's pretty simple to identify these things once you orient yourself and once you know what you're looking at. So that's going to do it for today's video, everyone. I hope you found that useful, and I will see you in the next one.